Hello students, in this week's video, we're going to do some problem solving involving tangent and normal line, increasing and decreasing functions. So do get a pen and some papers and practice along with me. We will be working on the problem sums from exercise 13.1. For a start, let's look at some basic questions. In question 1, we are asked to find the equations of the tangent to each curve at the given point. So to find the equations of the tangent, we will need the gradient and one point. And that point is given 2, 4. So let's work on how to find the gradient of the tangent line. So with that, we will have to find the derivative of the equations given, which is, if you differentiate x squared, you get 2x. So 2 times 2 gives you 4. So differentiating 2x squared, you get 4x. Differentiate negative 3x, you get negative 3. And differentiate 1, you get 0. So that is the gradient function. So at x equals to 2, the gradient of the tangent line would be 5. And to find the equations of the tangent line, I'm using this formula. This is a very useful formula. It's actually derived from finding the gradient if you're given 2 points. So x1 to y1 represent the point that is given to you, which is 2, 4. So your x1, y1 represent 2, 4. So let's substitute all this information into y minus y1 equals to n bracket x minus x1, and let's see what we get. y1 will be 4, x1 will be 2. Let's simplify it. So the equations of the tangent line will be y equals to 5x minus 6. So I'm going to give you a graphical representation. So we have a quadratic curve, and at this point here, 2, 4, I have a tangent line. Okay, and this tangent line, the equations of it will be y equals to 5x minus 6. Okay, let's proceed to point B. Right, if you were to compare part B, if you're going to compare part B with part A, you'll see that you're only given the x coordinates. The y coordinate is not given. Right, so we will have to find the y coordinates, which is by substituting x equals to negative 1 into the equations of the curve, and you'll get y coordinates to be negative 12. So in this case here, our x1, y1 will be bracket negative 1, negative 12. Right, so let's go on to find the gradient of this tangent line at x equals to negative 1. So to do that, we need to find the gradient function. So differentiating x cubed, you will get 3x squared. Differentiating positive 6x, you get 6. Differentiating negative 5, you get 0. So we're going to substitute x to be negative 12. And the gradient of the tangent line will be 9. And using the formula that we have learned earlier on, y minus y1 equals to n bracket x minus x1. N refers to the gradient of the tangent line. Let's substitute in all the informations. This will give you x plus 1, y plus 12. Right, and you have y plus 12 equals to 9 times bracket x plus 1. Simplify further, you will have y equals to 9x minus 3. So if I'm going to give you a graphical representation, this is a cubic curve, but we don't really have to worry how the curve looks like. Right, so at this particular point, x equals to negative 1. Okay, the tangent line must touch the curve. Right, just touch it as only one point. So this particular tangent line, at this point here, x equals to negative 1, y equals to negative 12. The equation is y equals to 9x minus 3. Right, let's look at question 5. So for question 5, we have upgraded ourselves. Okay, now we are required to find the equations of the normal line. And also, if we were to look at the curve that you're given, it is more difficult to find the derivative. In this case here, we will have to use the quotient rule to find our dy dx. So step number 1, let 3x plus 1 be u, 1 minus x be v. Let's find the u over the x, which is 3. Differentiating 3x, you get 3. Differentiating 1, you get 0. The v over the x will be negative 1. Write down the formula to find dy dx. Right, this formula, you will have to remember it. It's not difficult. If you have remembered the product rule, basically instead of a plus, this one is a minus, then over v squared. Alright, so let's substitute in all the informations. Let's simplify it. Just watch out for all this sign that negative times negative gives you a positive. Simplify further. Alright. So if I'm going to give you a graphical representation, it means that you have a curve. We don't have to worry how the curve looks like. It's not necessary to know the exact shape of the curve. We just know that there is a normal line, but before the normal line, you should always work on the tangent line first. Okay, the tangent line will come first, and then the normal line. The normal and the tangents are perpendicular to each other. So this is your tangent line. And this one, it's the normal line. Alright, so what is happening is this normal line will intersect the x-axis. So I would have an x-axis here. And the normal line will intersect at this point here. Alright, so before we can find the equations of the normal line, we will need to find the gradient of the tangent line. Always remember, you need the gradient of the tangent line. Normal line is dependent on the tangent line, so we need the gradient of the tangent line first. So we're going to substitute. We will need to find your x-intercept because we need to substitute the values of x. So we need that value. So when it says intersects the x-axis, okay, that is the key point, intersects the x-axis. That is when you let y equals to 0. Okay, you can do a cross multiply, or you multiply both sides by 1 minus x. That will just give you 3x plus 1 equals to 0. That will give you x equals to negative 1/3. Alright, so with that, you can substitute into your dy dx to find the gradient of the tangent line, which is 9/4. And we know that the gradient of the tangent line times the gradient of the normal line gives you negative 1. So therefore, the gradient of the normal line will be negative 1 divided by 9/4. Gives you negative 4/9. Using the same formula that we have learned earlier on, y minus y1 equals to m bracket x minus x1. Substitute in your x1, y1. In this case here, your x1 will be negative 1/3 and your y1 will be 0. Simplify it, and that is how we find the equations of the normal line. Right, let's look at this question here. So we have a curve, this n-shaped curve. How do you know it's an n-shaped curve? If you look at the coefficients of negative x squared, that is negative 1 times x squared. So the coefficients is negative 1, so it's an n-shaped curve. So on this n-shaped curve, right, we have a point P, right, and this point P has x coordinate x equals to 1, so that's point P, right, and then the tangent to the curve at P meets the x-axis at A and the y-axis at B. Alright, so let's do a proper drawing first. Since we know that it's an n-shaped curve, let's have your x and y-axis. Right, so when x is 0, the y-intercept for this curve will be at negative 6. don't need to be very accurate. We all know it's just an n-shaped curve, something like this, okay? Then at x equals to 1, let's say this point is x equals to 1 here, we have a tangent line. Oh, great. Tangent line should not cut through the curve. So maybe I have my tangent line here. Alright, so this is point P. This is where x equals to 1. That is our tangent line. Right, and this particular tangent line will cut the y-axis at point. This point here will be B, as stated here. And then cuts the x-axis at point A. Alright, always the origin, and we asked to find the area of this, highlighted in yellow for you. Right, so before we can find the area, yeah, this is a right angle triangle, quite obvious. So we can actually use half base times height. So I will need to know all this length. Right, so to find this length, I would have to find the equations of the tangent line. Okay, so our job now is to find the equations of a tangent line. Right, so to do that, we need the derivative, because the derivative will help us to find the gradient of the tangent line. Right, so our derivative will be dy over dx, which is negative 2x plus 4. Okay, so at x equals to 1, right, that will be 2. Okay, right, so before we can actually go on to find equations for tangent line, we need to know our x1, y1. That means we need to know when x is equals to 1, what is our y coordinates. So when x is my y coordinate will be and that gives you negative 3. So basically my x1, y1 will be 1, negative 3. Okay, so we can go on to find the equations of our tangent line. Which will be y minus y1 equals to gradient x minus x1. So y1 will be negative 3. Make sure you bracket it. Gradient is 2. x1 it's 1. So if you were to simplify it, you get y equals to 2x minus 5. So this will be my equations of my tangent line, but we're not done yet because we need to find point A and B. So for point A, this is when I let y equals to 0. So you have x equals to 5 over 2. Then for point B, this is when I let x equals to 0. So my y will be negative 5. Right, but if you're finding area, of course we will ignore the negative. Right, ignore the negative. Oh, okay. Which means my curve, my tangent line, it has to go, okay, never mind, I will revise it. Right, so the area will be, it's okay because the first time when you draw, you don't know what are your x coordinate for point A and y coordinate for point B. So you just draw it and then you realize that y is actually negative 5. So in other words, your straight line Your x is a positive value. Your y is a negative value. Gosh, so how do I draw my straight line? So you will have to cut like that. Okay? Yeah, so this is your point A, and that is your point B. All right? So area of triangle AOB will be half times 5/2 times 6, and that gives you 15/2 unit square. All right, put in the unit square yourself. All right, in the earlier slide, I actually substituted the values of the y coordinates for B wrongly. Right, so the area of triangle AOB, it should be half times 5, not times 6, because the y coordinates of point B is 5. See, make a mistake again, it's 5. So half times 5 times the x coordinates of point A is negative 2.5, but we know the negative because we're finding area. So this will give you 6.25 unit square. All right, so we solve part I. So for part 2, all right, let's look at how the diagram will look like. Okay, so what is happening now, it's if you were to recall, we have a point P here, right? And then you have the tangent line. The equations of this tangent line is y equals to 2x minus 5. What we are saying is that we have a particular point Q here, okay? And the normal at point Q is parallel to the tangent line at point P. So let's draw a tangent line first. Before we can draw normal, always have a tangent. So tangent line at point Q is like that. And then from there, we can have a normal line. Let's use a different color. So, same color. Okay, never mind. So these two lines actually are perpendicular to each other. Okay, so this is my tangent line. All right. And this is my normal line. And this normal line is parallel to my first tangent line. So therefore, the gradient will be the same as the gradient of my first tangent line, which is 2. Okay? Right. So we basically have to work backwards a bit to find this point Q. Our job is to find the coordinates of point Q. So given, okay, given if the gradient of the normal line is 2, then gradient of tangent line will just basically -1 divided by gradient of your normal line, right? Because both of them multiply together gives you -1. So one is -1 divided by the other gradient. So that gives you -1/2, right? Okay, and we're going to let your derivative equals to -1/2. So originally we also found our derivative will be -2x plus 4, right? So we're going to let this equals to -1/2. So your x coordinate is 9/4. That means your point Q, your x coordinate is 9/4. So we still have to go on to find my y coordinates. So I will have to sub into your equations of the curve. Let's do it here. Right, that gives you negative 17 and 1/4. So therefore, your point Q would be x coordinate is 9/4, y coordinate is negative 17 1/4. Okay, again, you see my diagram is not really drawn to scale. You can't possibly draw to scale because you don't know the exact location. So diagram just give you a rough idea how you can go about solving the problem. Okay, but there's no need to redraw the diagram after knowing the correct value for point Q. Okay, right. So in the earlier slides, I make a mistake in my calculations again, because to find the coordinates of Q, right, we already found the x coordinate to be 9/4. Right, so you have to sub x equals to 9/4 into the equations of the curve. Right, and then I did a calculation error here. That will gives you negative 2 1/16. So therefore your coordinates for point Q will be 9/4, comma. Alright, so be careful with the calculations. If not, for all the troubles, right, for all the hard work you put in and then the final answer is wrong, that will be quite disappointing. Okay, let's look at the next questions. Alright, this questions, the diagram is provided for you. Okay, I like it is when they provide diagram for you, because the picture actually tells 1,000 words. Right, so what happened is that you have the tangents to the curve at point P meets the coordinate axis at point B and D. Okay, so basically this is your tangent line. This one is your tangent line. Okay, I am the tangent line. Okay, ho. Right, so I'm the tangent line. Right, so what happened? Find the coordinates of point A. Okay, right. So they give you point B and D. So there are several questions you have to ask yourself. If you're given 2 points B and D, what informations are they trying to give you? So basically, when you do problem solving, it's a series of asking yourself lots of questions and giving yourself the answer. When you're able to give yourself the answer, that is when you're able to solve the problem. Right. So give you 2 points, and then we're talking about equations of straight line, right? So equations of straight line will involve gradient lah, y-intercept lah, derivative, your dy, dx, so on and so forth, right? Yeah, so 2 points, what can you find using 2 points? Correct, you can find the gradient of BD, which is you use your y2 minus y1 over x2 minus x1, and that will give you 11 minus 0 over 0 minus bracket negative 2.2. Right, so that gives you 5. Okay. And how do I go about finding? So this 5 is actually the gradient of your tangent line. Right, it's the gradient of BD, and then BD is actually a tangent line, right? Right, so we need to fall back to our derivative, right? So given y equals to x squared plus 7x plus 12. So this question is similar in concepts to the questions earlier on for finding the coordinates for point Q. It's the same concept. You get the gradient, you get the derivative, you equate the derivative equals to your gradient. So your dy over dx will be 2x plus 7. And then we just equate 2x plus 7 equals to 5. you will have 2x equals to negative 2, x equals to negative 1. Okay, then we need to substitute x equals to negative 1 into your curve. Your y coordinates will be, make sure you bracket it because x is negative 1. And that gives you how much? 1 minus 7, negative 6 plus 12, 6, right? So therefore, your point A will be negative 1, 6. Alright, so that's how you do part I. Let's look at part 2. The normal to the curve at A meets the x-axis. Okay, so this one is your normal. Okay, use a different color. I am the normal. I'm the normal line. Okay, he. Or hey. I'm the normal line. So the normal and the tangent line are perpendicular to each other, right? Find the coordinates of C. Alright, so we can find the gradient of our normal line. Which is basically just negative 1 divided by the gradient of your tangent line, which is 5, so negative 1/5. Okay, so we need to find the equations of the normal line. We need to find equations for normal line before we can find C. Alright, so therefore equations of normal line will be y minus y1 equals to gradient x minus x1. So your y1 and x1 is basically your point A. That will give you minus 1/5 plus 6. So you simplify further, that will be y equals negative 1/5 x. I don't have a calculator. I'm relying on my mental calculation. I hope it doesn't fail me. Plus 29 over 5. Alright, so that will be your equations of a normal line. So what's next? You need to find point C. So point C is when your y is, point C, it's a point on the x-axis. That's when the y coordinate is 0. X will be equals to 29. Right, so therefore your point C will be 29, 0. Okay? Right, so the next thing is to find the area of a triangle ABC. Okay, I'm running out of space. I'll see you at the next slide. Right, I think for these questions, a lot of you would go on to use the distance formula to find AB. Using your distance formula, right, which is your x2 minus x1 squared plus y2 minus y1 squared, right? And also use the distance formula to find AC. Okay, and then finally half base times height. I think you don't do that because, I mean, if you want, you can just go ahead. Just that there's a shorter method, a more efficient method. So what is the efficient method? The efficient method is you can actually use this as your height and this as your base. Okay, so the height is actually just 6 units. Because if you look at the coordinates of point A, y coordinate is 6. So basically, this line here is 6 units. Okay, and then from here to here is just 1 plus 29. And here to here is just 2.2. So this whole length here will just be 2.1 plus 1. Sorry, wrong. Let's try again. Here to here, basically just 2.2 only. Because you look at point B is negative 2.2, means from here to here is 2.2. Then here to here is 29. So the base will just be 2.2 plus 29. That gives you 29, 30, 31, 31.2. Right, so therefore area of triangle ABC will just basically be half times 6 times 31.2 gives you 93.6 units square. Okay. Right, let's look at the next question. This is rather challenging questions. You're given two curves, y equals to x squared and y equals to negative x squared plus 8x minus 16. So you ask how many lines are tangent to both this curve. What they're trying to say is, just give an example, okay? Like if you have, all right, y equals to x squared, basically the curve, this is how it looks like, y equals to x squared. All right, then this one is an N-shaped curve. Don't have to explain again y. Y-intercept is negative 16. So the curve will be like this. Wait. Oh, no, it's not. Because if you were to factorize it, right, so basically there's only one x-intercept, which is here. So this is how your curve looks like. Right, so clearly from the curve, we can see that from both curves, we can see that they're actually two tangent lines. If you see, the first one is this, x equals to, the x-axis is actually a tangent line because x-axis touched your y equals to x squared at one point here, right? Also touched, this is 0. Also touch the second curve at x equals to 4. Right, so there will be one tangent line. Then the second tangent line will be, I suspect is somewhere there like that. That will be the second tangent line, right? But I think you are not expected to use the curve to show that there are two tangent lines. You're supposed to do it algebraically. So having drawn the curves is a way to help you understand the problem. You see, one of the ways of understanding the problem is to use diagram. So when you use the diagram to understand the problem, it kind of guide us into solving it in the algebraic way. Okay, so how do we do it? So we know that there should be a tangent line. Okay, the green color one, there's a tangent line. So we're going to find this tangent line. We're just going to assume that there's a point P on y equals to x squared. It's easier to work on y equals to x squared than the other one because there's no x-intercept for y equals to x squared, so it's easier to work with. So let's have a point P there, and let's call it, let the x coordinate be A. So when you substitute x to be A, then A squared will be your y coordinate. Okay, so the first step is let P be a point on y equals to x squared. Alright, so we're going to find the equations of that tangent line. Okay, right, so dy over dx will be 2x, right? So we're going to sub x equals to A. So our dy over dx will be 2a. Alright, so we're going to find the equations of that tangent line. At point P will be y minus, okay, the equations I'm doing, it's actually we've done it many times already, so I'll just write down again for some of you. Ooh. Alright, so y minus, so y1 is a squared. Gradient is 2a. x1 is a. So we're going to simplify it. Alright, so this is the equations of my tangent line at P. And of course, this tangent line is expected also. Can you see that it's expected also to be the tangent line for this for the second curve? Alright. So that means I have two equations here. I have the equations of my tangent line, and I also have the equations of the second curve. Alright, so I'm going to generate equations, solve them simultaneously, generate equations in terms of x only. Alright, so I will have negative x squared plus 8x. Okay, I think I need more space. Okay, I bring the 2ax to the left. So factorize the x out, you get 8 minus 2a. Then minus 16 plus a squared equals to 0, right? Alright, so if you were to record in the chapter when we learn discriminant, when we learn no real roots or real roots, or real and distinct roots, real and equal roots, this is the case where if a tangent line and the curve, we're talking about two real and equal roots. That's when the discriminant is equals to 0. So this is where I'm going to use that. Alright, let's factorize it. Wait, hang on, I have to be careful with the sign. This is negative. So that will give me 8a squared minus 16a equals to 0. Okay, let's continue from here. So let's factorize 8a out. So I would have a equals to 0 or a equals to 2. Right, so then we are saying that that's possible of having 2 points. Because P is just a point on the curve, right? P is just a point on the curve, on this curve. So there are two possibilities. First possibility is when your values of A is 2, that means the green color one, this one. Okay, let me substitute now. Okay, first of all, you have to understand that P is a point on the curve y equals to x squared. So P can be anywhere on the curve. So now we have two values for A. A can be 2. So if A is 2, then this is the point we're talking about here. And because P can be anywhere here, anywhere here, the second point possible is when A is 0. And when A is 0, is your P is there. Okay? So it kind of makes sense because when P is equals to 0, 0, can you see? Just now we agree, right, that this can be a tangent line to both curve, and this can also be a tangent line to both curve. So from all this explanation, we can just say that there are two possible position for there are two possible positions for point for P, which is P can be at the origin and P can be at 2, 4. So therefore there are two tangent lines. Okay. Right, in the second part of this video, we'll be solving questions from exercise 13.2. Right, let's look at question 4. Question 4, we're given the equation y equals to 2x over x plus 1. We need to show that it's an increasing function. Alright, the key word here is to show that it's an increasing function. What are the concepts involved here? If it's an increasing function, if y is an increasing function, then your dy over dx would have to be more than 0. The values of dy dx will have to be more than 0. If y is a decreasing function, then the value of your dy dx would have to be less than 0. So basically, these are just the two concepts that you need to know for increasing and decreasing function. All right, so first thing, we have to find the derivative, which is your dy dx. And if you look at the equations of the curve, you are given a fraction. So we're going to use the quotient rule to find your dy dx. So step number 1, let 2x to be u, let x plus 1 to be v. So du over dx will just be 2. Because you differentiate 2x, you get 2. And dv over dx will be 1. Because you differentiate x, you get 1. Differentiate 1, you get 0. Write down the formula. Substitute in all the information. Simplify it. And this is what you get. Alright. So this is the questions on showing that it's an increasing function. So we basically have to explain. We need to do some explanation. Why is it that your dy dx will always be more than 0 for all real values of x, except for x equals to negative 1? What happens if x equals to negative 1? You would end up getting the denominator to be 0, and it's undefined because you can't have 1 divided by 0. You can't have something divided by 0. It's undefined. So therefore, there's this condition here that says that x cannot take the value of negative 1. All right, so how do we go about explaining it? Let's take a look. So first, we observe that the denominator is more than 0. Because x cannot be negative 1, so it definitely has to be more than 0. And if your denominator is a positive value, 2 is a positive. 2 divided by a positive will give you a positive value, which is more than 0. And there we prove that, yeah, dy dx is more than 0. So therefore, y is an increasing function for all real values of x, but x cannot be negative 1. So look at how you should answer the questions, the sequence of it. First of all, find your dy dx. Okay? Explain the possible values for the denominator, which is always more than 0. Write down the condition for it not to be equal to 0. Then go back to your fractions and explain that you would always get more than 0 because denominator is 0, more than 0, numerator is more than 0. Therefore, the whole thing will turn out to be more than 0. And therefore, your dy dx is more than 0. And so therefore, y is an increasing function for all real values of x. That means regardless of what you put inside x to be any value except negative 1, you will always have this guy more than 0. So this is how you do approving questions. Alright, let's look at a O-level questions. In fact, this is easier than the previous one because in this question here, you are not asked to show anything. You're given. Can you see? You're given in part 2 that y is a decreasing function. You're being told in the questions that is a decreasing function. So there's no need to show anything like what we have done earlier on. You can just use dy dx less than 0. But let's do part I first. And if you look at part I, all right, what you're given is x minus 2 multiplied with bracket 2x minus 5 to the power 3. So in this case here, we will be using the product rule. Where we let x minus 2 be u, bracket 2x minus 5 to the power 3 be v. Let's find our du over the x, which is 1. dv over the x is, I hope you remember your chain rule. You will have to bring the 3 to the front. The 3 minus 1 to get 2. And differentiate the inside, the bracket. Differentiate whatever that's inside the bracket. So differentiate 2x, you get 2. Differentiate negative 5, you get 0. And if you take 3 times 2, that's how you get your 6. And the next thing is write down the product rule, which is easier to remember than your quotient rule. Plug in all your information, plug in your v, your du, dx, your u, dv, dx. Alright, so we need to take out some common factor. You see that this and this are common. There are 2 of these and 3 of these. So we just take out 2 of them. If you take out 2 of them, you're left only with 1, 2x minus 5. Here you take out both of them, so you're left only with 6 and x minus 2. And simplify those things in the huge square bracket. And that is how you do part I, which is manageable. So let's go to part 2. As what I've mentioned just now, you are being told in the question that y is a decreasing function. So go ahead and use it. Be brave. Alright, so how do we use it? Yes, dy over dx will be less than 0. Okay, and we know that this one will always be positive. For all values, all real values of x will always be more than 0. Except for x equals to 5 over 2, but I think that's fine now. So that will be always more than 0. So but you want the final products to be a negative value. So if this guy is plus, this one has to be negative. Plus and minus then gives you negative. So 8x minus 17 will have to be less than 0. X will be less than 17 over 8. Not too sure if I need to say x cannot be 5 over 2. Because if x is 5 over 2, then it does not make sense to have 0 less than 0. So probably I need this thing. Alright. Alright, let's look at question 10. So question 10, the difficulty, the level of difficulty is harder. Why harder? Because it involves an unknown here, p. Alright, it involves an unknown p. And we asked to find the range of values of p such that y is an increasing function. So do not have to worry if you have questions that does not look familiar to you. Meaning it's something different from what we have done earlier, right? The concept involved here is you still have to find your dy dx. So that is the first thing you still need to do, which we're going to do it now. Finding dy dx, which will give you 12x squared plus 8px plus 16. You can factorize. Oh, I didn't factorize it yet. Then you're given that y is an increasing function. You're given here, y is an increasing function. So again, go ahead and use it. Whatever you're given, use it. So dy over dx is more than 0, which means that whatever functions you're given, which is your 12x squared plus 8px plus 16 is more than 0, you can factorize your 4 out. so that you can get 3x squared plus 2px plus 4 more than 0. Okay, one of the ways to do problem solving is using diagram. If you don't quite understand how to go about solving problems, use a diagram. Use a diagram to try to understand it. So if I'm going to draw the diagram to represent this, okay, first of all, it's a curve. It's a quadratic curve because you're dealing with x squared, and it's a U shape because the coefficients of x squared is 3 positive value, right? And you see that for all real values of x, this curve is always positive. So pause here for a while and think, how do you think the shape of the curve will look like? It's a U shape, I know, but does it has any x-intercept? Yes, they won't have any x-intercept because for all real values of x, whatever you put inside here, here, the value come out will be positive more than 0, which means it is above the x-axis. So how do you think the curve will look like? Yes, it will be like this. Dun, 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 dun. Correct. Okay. And what does this kind of curve tells you? So go back to your database and think, in which chapter have I done this? In which chapter have I seen a curve like that? Does not touch the x-axis. What does it mean by it does not touch the x-axis? Means it has no x-intercept. It means it has no real roots. So what do you understand by having no real roots? So you think, and you say that, yeah, it's related to this thing called the discriminant. It's when your b squared minus 4ac is less than 0. Let's substitute in the values of b is the coefficients of x. So a is 3. Right, then plug in all the values there. And you get 4p squared minus 48 less than 0. So 4 is a common factor. Right, and then the next thing is that, oh my goodness, how do I solve a quadratic inequality? Yes, that's a quadratic inequality. So you have to go back to your database again. Go back. How do I solve a quadratic inequality? And you think and say, yes, we need to draw the quadratic curve. But before that, let's factorize it. And how do you know how to factorize it? This will link to your a squared minus b squared, which gives you a minus b, a plus b. And then, look, square root 12. What concepts is related to surds? Yeah, square root a times square root b is equal to square root ab. So that means by square root 12, I can simplify it into square root 4 times 3. That gives you 2 square root 3. Okay, but we are not done yet, right? Because just now we say that to solve a quadratic inequality, I need to have the quadratic curve. And I need to have the 2x intercept, which is negative 2 square root 3 and 2 square root 3. And I want, this is positive, and that's negative. I want the region that is negative. Yes, I want the one that's highlighted in yellow. And how do I describe the region? Correct. P will be between negative 2 square root 3. I make a typo error here. It's positive. P will be between negative square root 3 and 2 square root 3. And that's how we do question 10. Right, let's look at the last question. This is really the most challenging questions of all the other questions. Yeah, but don't worry, let's do it together. Right, so you're given a curve which is y equals to x squared minus 2x minus 2 over x minus a. A is a constant, means a can be 1, 2, 3, 4, 5, negative 1, 2, it's just the real values. When you say a is a constant, it's just the real values. So for what values of x is y increasing? Okay, so supposing if you look at these questions and you have no idea how to go about it, just go back to the basic concept, which is basically you need to find your dy dx. So if you don't know how to solve these questions till the end, at least you have some marks for finding dy dx. So since you're given the fraction, so we're going to use 1 product rule, 2 quotient rule. Yes, of course, we'll use the quotient rule. If you're given the fraction, just go and use quotient rule, okay? Don't go and change it to product rule. It'll be more complicated. So you let the numerator be u, which is x squared minus 2ax minus 2. You differentiate it, you get 2x minus 2a. Let the denominator be v. So we find dv over dx, that gives you 1. Plug into your formula. Okay, and this is what you get, right? So slow motion a bit, because this question is not easy. So we go slower a bit. So let's simplify the numerator. Be careful with all this negative, all this thing. You have to watch out for all this so that you won't make mistake. All right, let's simplify the numerator, which is not difficult. So I don't think I need any explanation. All right, so supposing you don't know how to continue from here, at least you can get some points for finding dy dx, right? But you can still continue further. Why? Because you're told that y is increasing. So you can actually still get 1 mark. 1 mark for doing what? Do you know? Right. So if you do know how to continue, at least if you know that y is a increasing function, then the dy dx should be more than 0. So just by writing like that, you will still get 1 mark for your concept. So maybe you're not strong in the algebra, but if you're strong in the concept, you can still get a few points. All right, so let's examine this fraction. So obviously the denominator cannot be equal to 0 because something divided by 0 is undefined. And if you look at the denominator, it's definitely more than 0 because you're squaring it. Square something is always positive value. So we explain it like that. We say since that bracket x minus a close bracket to the power of 2 is more than 0 for all real values of x except x cannot be a, as what I explained earlier on just now, it cannot be 0, then the numerator must be positive because in the end you want to end up, you want everything to be positive, right? So bottom positive, top also must be positive, right? Positive divided by positive, then positive, right? So here the way I do it is I complete the square for this. Why do you want to complete the square? Because if I make it a completed square, then it's easier because anything to the power of 2 will be a positive value. This is what we're interested in, right? Isn't it? We're interested in something that's more than 0 because 2 definitely is positive. 2a squared also is positive. So the only thing that make us difficult, that's in our way, okay, in our way is these two terms, this irritating 2 terms. So we apply completing the square. So the coefficients of x is negative 2a, you divide by 2 gives you negative a, right? So you add and then you minus, right? If you cannot remember your completing the square, please go and revise. Okay, so that will give you this. All right. So that's examined. So we know first of all x cannot be equals to a. All right, here. So what can x be? Basically, x can be anything that's more than a. It can be 2a because 2a minus a will give you positive. It can also be less than a, which is negative 3a, because negative 4a times negative 4a will still be positive. So basically, your x can be anything that's less than a or more than a, but cannot be equals to a. Okay, that's how we do it.